we need to figure out this thing called MVT. So we have an IVT. What does that stand for? Intermediate value theorem, which is talking about some sort of in-between y value. Talking about like a function being continuous. You can use my height as an example. For some reason, Kyle always remembers this. You just brought it up like a million times.
No, someone asked, what's IVT? And I go, she may be this tall, but she has a good state.
Everything in between. Okay, so intermediate value theorem, in between y value. EVT. What's that one stand for? Extreme, but yeah, extreme value theorem, which means there will be a highest, there will be a lowest y value. We're still in the y value category. Function value. If a function is continuous on what kind of interval? Closed. Good. On a closed interval. Endpoint to endpoint. And then there's like a little like how to find the absolute extrema, and if it's continuous on a closed, you do this with the little table and the testing, the critical numbers and the endpoints, and if it's not, we have to learn the rest of the chapter. MVT, mean value theorem. Here's where it gets a little tricky. Not with mean, that's easy. Mean in math means average. And average in calculus should make you think of average rate. F of B minus F of A all over B minus A. Is that in the card? Yes. On the right-hand side. What's on the other side? F prime of C.
The derivative.
Now, C is just a special x value. X equals C is a special x value. We've seen that for critical numbers because x equals C was just like the special C, or the special x, where critical numbers exist. But this one, it's not talking specifically, in case you get confused, it's not talking about critical numbers. It's talking about special x values where this is true. What is true? Who is f prime of C? Nope. The original is way back here, f. That's like intermediate value here, EVT, IVT, talking about f values. Hold on, who's f prime of C? It's an easy answer, it's not a hard answer. F prime means derivative. Yeah. This is derivative. Now, in context of rate, because this is the average rate formula, in context of rate, what's the description of the derivative that applies? Louder!
Instantaneous.
Okay. Katie, love you. Instantaneous rate. Your projection could use improvement. Instantaneous rate will equal the average rate at certain x values in the closed interval. So what do? I just wrote it on Friday. You guys got it. Period 6 did not. Take a derivative, find the average rate, set them equal, and solve. Solve for what? What's unknown? This is a number. This is an equation. What's inside the equation? An x. So we're going to be taking a derivative. Get those derivatives simplified. We're going to be finding average rates, going back to motion, and we'll be setting them equal and saying, when does this happen? Mean value theorem. There is a value. There is a value where the mean will equal the instantaneous. This is where it gets a little weird because IVT and EVT have guaranteed y values, function values. MVT says there's a guaranteed derivative value. All of a sudden we've jumped categories from the original function to the derivative. So, graphically, we'll come back. Hold on, Kathleen. Graphically, she was wondering about this whole roles theorem thing. Graphically, you guys sketch this, and this is asking out approximately, just using the graph and like eyeballing it. Homework has a couple of these. At what x values, at what special c's on the interval 0 to 7, closed interval from A to B. Sorry, B. We should probably mark those. Here's the 0. I think it hits around 0, 1. Here's the 7. It hits around 4, 6. It's not 7.7. Something awkward. That's okay. We'll just mark it. It's a little bit above 6. Does the graph of f satisfy? We were talking about motion, average rate, instantaneous rate. How do we apply that to a graph? Wait, derivative. Instantaneous rate, but think in context on a graph. What is a derivative on a graph? Or how do I see a derivative on a graph of his f, of his original function. Skimming. Why? Because derivatives show slopes of tangent lines. Okay, so on a graph, derivatives are slopes of tangent lines. Oh, what's the average on a graph? y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus... Isn't that just a slope? Cutting through the graph? Oh, so couldn't this also be? If you want to add it, you can. You don't have to. Average would be the secant that just cuts through from A to B and says, oh, hey, on average, what's the rate? Whereas instantaneous is going to be the slopes of the, right? So we can also say the tangent slope has to be equal somewhere to the secant slope, at least one place. Technically, at least one place, maybe more. So I'm going to go ahead and then grab this little guy and say, okay, you need to connect the little Mr. Secant line, A and B. All right, do we see the secant line? Right? What would his slope be? The average rate. True? Now, it could be actually like, I don't know, approximate numbers and find, I suppose. But we don't even know what the function is, so we're not going to be able to take his derivative. Maybe it's a cubic. Oh, nope, because it comes back down. Okay, forget it. Nope. If we wanted to, we could go into our calculator, find some points, and then put them all in, put as many as possible, and try to run a quintic regression, and maybe we'd find it. I don't know. It would have to be a 1, 2, 3, 4, 4th degree regression. So coming back. Who cares? We have the average rate. Do you guys see any x values where it seems like the tangent slope would be the same as the secant slope? Why is 1.5 not one of those places? What's the slope at 1.5? 0-ish, right? Is that the same as this guy? No. Why can the answer not be anywhere between 2 and 4? What's true for all of those values? What kinds of slopes? Downwards facing, negative slopes. That's not good. Can anybody find a place-ish where the secant slope is? Between 1 and 2? 5 and 6. Oh, 5 and 6. Yeah, that's a good place. So if I was going to take this, couldn't I make it parallel-ish? What do you guys think? Parallel-ish? Good enough? But to be a tangent line, what do I need it to do? Skim. Where's it going to skim? Ooh. Ooh, nice. Closer to 5. There's one. I don't know why it does not look parallel anymore, but oh well. This was parallel seconds ago. Okay, is there any other place? MVT says there's at least one. Could there be more than one? Sure. Is there another one?
Above it?
On top. On top. This way or that way? Left or right?
Right.
Right? Sure. Is there one up there?
No, left.
Is there one up there?
Oh, yeah.
See it? Now, oh, it touches. Oh, forget it. It skims right there. It skims.
Addie.
Okay.
Yo.
Another one?
Yeah, there is another one. Do you see it?
Yes.
How about this way?
Oh,
Woo!
oh.
Are there any more?
No.
The AP loves to ask things like, how many are guaranteed, or how many times will MVT be satisfied giving you a graph, which is a little confusing unless you realize this positive slope will only be realized, look at those curvatures, right? Will only be realized 3 times. Now, we might not know exactly where they are unless we have some way of solving, unless we have some sort of equations. And we're going to be dealing with equations in a second where we will be solving precisely for where, for what x is, for where these will occur. But graphically, you can tell how many times this will happen even if you don't have all the specific information. So, MVT, what's it talking about? A guaranteed derivative value, where the derivative must be the average, because derivative is instantaneous. So instantaneous rate must equal average rate. Tangent slope must equal secant slope. But how do we do it? We find a derivative, we find an average, we set them equal, solve for x. And just for a few of you, that might actually be something good to put on your forever card, but let's actually go practice it. However, before we move away from the graph, what does this little extra note that has a whole theorem attached to it that we're not really making you memorize, what is this little extra note? What extra piece of information is it saying? Like, and if this is also true. Yeah. So in the graph, well, no, this is like a little, this implies, so right here. If f of a equals f of b, what is this talking about? On the graph, where is f of a and where is f of b? F of a, the 2 points, right? These are the two y values. F of, that's the y at a and the y at b. So the y at, who's our a? 0. The y at 0 is 1-ish, right? And the y at 7 is 6-ish, 6.5-ish, I don't know. Okay, so we have 6-ish and we have 1-ish. Are these the same? No. And more specifically, f of b is higher than f of a, so our average is going to be a positive number. If they were switched, our average would be a negative number. But they're saying, what if they are the same? What would the secant slope, what would the green line, what slope would it have had if they were the exact same? Good, it would have been a flat line, right?
1, 2, 3.
Oh, well, if it's a flat line, the secant slope will have to equal the derivative tangent slope, so then the derivative must be 0. So why did I write f of b?
F of b minus f of b?
Yeah, why did I write that? I mean, it makes sense on the graph.
Because f of a equals f of b.
Because f of a equals f of b, so all I did was a quick substitution, showing mathematically, well, if they're the same, they're going to be the same. I could have also made it f of a minus f of a. Just that one looks weird. I like f of b going first. Okay, anyway. So literally, this is just a special case that only, and I meant it that time. I usually do. Chapel. Coming back. I wrote it because the graph part makes sense, but I need you guys to also realize what's going to happen in the equation solving part. And guys, there used to be a whole extra forever card for Rolle's theorem, but do you see how it's, I'm going to say literally again, it's literally just a specific case of MBT? Yes. Something special that can occur. Okay, we have to get to equations. So, getting into our notes. Before we totally just like bust out equations and solving an algebraic, all that sort of stuff, let's just put in our notes a quick little what we saw about MBT with lines. Okay? So, have we actually put normal line into our notes yet?
No.
We talked about it.
We talked about lines.
Okay,
Yes.
so we'll do a quick little aside on a normal line too. Let's just do all the different lines. Calculus loves the lines. Look at that. John still gets it. This is good. Okay, so I'm lost.
Abigail.
What happened to Abby? No, it's Gail. It's been both.
No.
I get Gail.
Sorry,
I was
Ann.
like,
You like Ann now.
No.
Ann.
Andrea.
Coming back. We don't multitask well. Love you all. That's true. Okay, here we go. Tangent line. Y minus y1 equals n times x minus x1. What am I going to write for secant line? Y minus y1 equals m times x minus x1.
It's the same.
What am I going to write for normal line? Y minus y1 equals, you go.
1 over n.
Ah! Oh, well. I see what you're doing.
Boom. Reciprocal.
Nice.
Not yet. I'm going to do a little subscript of a T, a little subscript of an S, and a little subscript of an N. Why? What do you fill in for the tangent slope? What do you fill in for the secant slope? And what do you fill in for the normal slope? Guys, a line is a line is a line. Y minus y1 equals m times x minus x1. Where do the numbers go in lines? Where have they always gone and they always will go? Where do the numbers go?
On one the other side. What do you think?
In general, making an equation of a line, what do you need to plug in for?
X and
X1 and Y1. These just stay Y and X and the M. I need numbers in all of these spots, right? To have an actual line, I need numbers. Oops. I need numbers in all of those spots. Some of you are like, duh, we've been learning lines since algebra. I know, but I do the grading. I see the mistakes that get made. Which I can't show you.
Alright, we'll see.
Yes. Okay. How do we find a tangent slope? Assuming that these are to some function f, or of some function f. What would my tangent slope be?
I'm confused on what you're asking.
Okay, it's alright, I'll help. Don't we just take a derivative and plug in an x?
Yeah, okay, yeah.
But we have to plug in an x. We have to plug in a number, otherwise we won't get a number. So we take a derivative, plug in a number to get a value to plug into the n spot. For the secant line, don't we need to be able to do a secant slope, which means we need 2 points in an old-fashioned y2 minus y1 all over x2 minus x1. We need 2 points. We have one, x1, y1. We need the other one. And for normal slope, Kyle, you had the right idea of 1 over. You were missing one little piece and just telling me 1 over who or what.
It'd be f prime of x. Right?
But not of x, of a specific actual. Does that make sense? But I get it. But some people literally just do f prime of x and they plug in an equation and the line is definitely not a line. You laugh at me and I just have to grade it. Okay. No, just in general. I don't remember who. I was on a second page of the test, the beginning of the long answer, and I don't see names, so I just.
Oh, that would probably be.
I was at the beach and I was grading. It was very nice. Yeah, just for a little bit yesterday, a few hours. Okay. Now I'm not at the beach, but it's okay. You guys are more fun.
There's always thing you can do in California. Misty, right now it is snowing so much in the northeast and
Not applicable to us.
Why do we say mean when we could just say average? Like if they mean the same thing.
I'm sure it comes from, why do we say normal instead of saying perpendicular? It comes from Latin normalis, which actually meant, so maybe mean is, I don't know, a lot of math comes from Latin, so it's a lot of sense. But you should look it up. One of those random, hey Siri, what? No, just I know. Coming back. Lines, got him. Okay, so now it's time for us to play with roles and MBT.
Oh boy.
You guys notice, homework is going to be asking sometimes, does roles apply? And you're like, roles? Who's that guy? Oh, it's MBT.
Don't do it, Kyle.
It's MBT, where FA equals FB.
Please don't do it.
He's not. We're in class.
Oh,
We're in a class environment. We're going to stay.
He's done it before.
I'm just letting him know my teacher expectations. Okay, so, will roles apply? Will MBT apply? Guys, I just have the whole shabam on the board to say this is the algebraic stuff you might have to face in homework. Let's see if we can do it. Ready? For both pages. The following things need to be sure. F needs to be continuous. Oh, look, it's right here. F needs to be continuous on a closed interval. I say endpoint to endpoint must exist. F needs to be continuous on the closed interval. Endpoint to endpoint must exist. And then F needs to be differentiable on the open interval, aka smooth terms only or no DNEs of the derivative in between. Now, that's a little bit different because in between says open interval, endpoint to endpoint says closed interval. And then roles, well, he's that extra guy at the very bottom. Also, f of a must equal f of b. So ready for all of these. Can you guys see the functions? Are they too light? Can you see them now?
Yes.
Okay. Do I have to worry about f and its continuity for the first one? No, because he's what kind of function? When you multiplied him, he would be technically to the second, third power, but he's a polynomial. So it means all the numbers add. Wait, and polynomials in pre-calc, maybe you remember, maybe you don't, Mr. Che used my notes, have smooth terms only. It was back in chapter 2, long time ago. Polynomials, smooth terms only, aka, what is the derivative of a polynomial?
Another polynomial.
Nice! Which means, the derivatives domain will be all real numbers also. So is f differentiable?
Yes.
On the open interval?
Yes.
Oops. Open interval. Yeah. Why? He's a polynomial. What else has to be true for roles? He's the special note at the very bottom.
F of a must equal f.
F of a equals f to, or has to b. So we have to actually come off to the side and do a little bit of work. I'm going to do it not in red because that's my like derivative color usually. How about this? Blue. F of negative 1 equals F of 3. Actually, I'm going to do green because it's like old school, just plugging in algebra stuff. I have my algebra kid. Want to do this. I'm plugging in. Love them. All right. Plugging in negative 1. I get 0. Right?
Yes.
So that's a 0. Squared is 0. Times anything is 0. Equals plugging in 3.
0.
0. Oh my goodness. Does 0 equal 0?
Yes.
So does rolls apply?
Yes.
Yes. So I can say this is a rolls problem.
Anyone wants to know?
But what else does it say after I figured out rolls does apply?
Find any C values guaranteed.
Okay, so rolls says, oh, the same thing NBT does. F prime of C is equal to F of B minus F of A all over B minus A. But to actually do that, I have to actually find the derivative. Hey, what's still on the board?
Simplified.
No, get those derivatives simplified. So you have to find it and simplify them. It's a product rule.
Or is it?
Okay, guys, it's my job to teach you how to derive right now. No, it's just for you to practice. Getting them and getting them simplified. So, second B first, I'm going to have mine. Oops, no, second needs to be written. I'm just saying I'm going to go fast. Long story short. B first is just 1 plus first. B second, which is going to be 2 times 1. Green pen trick is super snazzy here because they both have an x plus 1, right?
Yeah.
So I'm going to pull out that x plus 1. Long story short, when you get what's left and you simplify, you get an x plus 1 and a 2x minus 6, and a 2x minus x makes a 3x. And then a plus 1 minus 6 is a plus, nope, minus 5. Careful, that was way too much mental math and just running out of room. Who is that? My f prime of x. What am I supposed to do to him? Second equal to f of b minus f of a all over b minus a. But what's going to happen if they're the same every single time? F of b minus f of b all over. Oh, it's 0. Sweet. Equals 0. At x equals negative 1 and 5/3. Which one or ones is guaranteed by the theorem? The theorem says only the ones inside. Who's inside? Justin.
Well, if it's closed.
It's continuous on the close, but if you memorize the theorem, which is why we do it, we're only looking, or it's only guaranteeing values in between. Think about your graphs. We didn't look at the ends, we looked in between for the tangents. So what did I do? Checked continuity, checked differentiability. For rolls, I checked the f of a equals f of b, and then I said, yay, everything's a go. So derivatives set equal to the average, but the average for rolls will always be 0. How does NVT change? Okay, NVT is f continuous. That's x cubed.
Oh.
But will it be continuous?
Yes.
Yeah, it's a polynomial, no big deal. But it has to be endpoint to endpoint. Has to be endpoint to endpoint. But yeah, it's good. I mean, polynomial's good anyway. Is f going to be differentiable without even taking a derivative? What can we say?
Yes.
Yes, because polynomials only have smooth terms. And polynomials derivatives are polynomials whose domain is all real numbers. Got 'em. You could go looking for does f of a equal f of b. This is actually just saying use NVT, so technically that's all we need. Check, check. Let's go. What does going for NVT look like? Deriving. So, after we know we're allowed to, or it's guaranteed, f prime of x is equal to 3x squared plus 1. Go team. But that's not finishing. F prime of c is one very small part, right? Yeah. So then I say, okay, now that I have my derivative, I don't have to work at simplifying. To find the c values guaranteed by the theorem, I say f prime of c, 3, if you want to, you can actually rewrite the derivative with a c inside. F prime of c says derivative with special x's. All right, fine, I'll call them c. Needs to be equal to what? Why am I coming up here in green and I'm writing f of 2 minus f of negative 1 all over 2 minus negative 1? What am I supposed to be doing over here?
You're finding the average rate.
I'm supposed to be setting it equal to the average rate and asking myself the question, when does this occur? But average rate. Why is it in green? Because it's like pre-cal. Maybe even algebra 2. I mean, function notation was algebra 2. We digress. Okay, so 2. 2 cubed is 8. 8 plus 2 is 10. 10 minus 4 is 6. Minus. Negative 1 cubed is negative 1. Minus 1 or plus negative 1 is negative 2. Minus 4 is negative 6. Ooh, be careful with your negatives or else you're going to make a mistake. That's a 12. All over 2 minus negative 1 is 3. And 12 over 3 is 4. Do I have my instantaneous side? Yes.
Yes.
Do I have my average side?
Yes.
How do I finish? It's an equation. You solve. So subtract 1, I get 3. Divide by 3, I get 1. C squared is equal to 1.
Plus or minus.
So C is equal to plus or minus 1.
So only plus 1 works.
So only, well, they both work, but only one is the one guaranteed because of my interval. Because remember, C has to be on the open in between. If you guys ever see like in an open interval, just think has to be in between if it's a closed interval from endpoint to endpoint. What was the difference between this and this? Between the rolls?
MBT.
Yes, there are different names. What else? How about the procedure?
Well, one we know
This part, well, the green parts were different, right? This guy said go plugging into average. This guy said go setting them equal to each other. Wait a minute. What if we just get into this whole like MBT rhythm? Maybe you remember, maybe you don't. I didn't mean to have green. The MBT rhythm of like, hey, pretty much. I'm gonna start telling you. If you need to remember one, just remember this one. What if you got into the MBT rhythm and you went actually plugging in f of 3 minus f of negative 1 all over 3 minus negative 1? The AP doesn't even use rolls, doesn't even use the name rolls.
0 over numbers.
Oh, is that what's going to happen?
Wait a minute.
Oh, because we plug in 3 and get 0. We plug in negative 1 and get 0. And 0 minus 0, we would get 0 over 4. Isn't that equal to 0? So even if we don't necessarily see that it's rolls, we don't see the endpoints are equal, if we go to plug into the average, which is why we memorize MDT, why he's the main card. If we go plugging in and get a 0, it's like, it's a rolls. Oh well, you just keep going, because the procedure is the same. Continuous, differentiable. If you did average, you would have gotten the 0 that f of a equals f of b told you. Whatever, take the derivative, set the derivative equal to whatever the average ends up being, and then find the ones in between. They're the same exact procedure, just rolls, I don't know, they want us to attach the little baby name to it. But could you technically do MBT for every single one? Yeah. Just if the f of b minus f of a all over b minus a was not 0, you would say not rolls, not that MBT wouldn't apply, but not rolls, and just stop. Wait, we get to just stop sometimes? Ooh. Hey, this one looks like a just stop one because it has a discontinuity, right? So that whole f is continuous on negative 1 to 6. It would fail, yeah? Because look, it doesn't exist at negative 2. Wait. It doesn't exist at negative 2. Is it continuous on the closed interval negative 1 to 6?
Yeah.
Because isn't negative 2 over here? It's fine there, it's just not fine there. Oh, I thought we'd be able to stop. Because guys, in any of your homework problems, if you get to show that one of them doesn't work, you get to say, it doesn't apply, and just stop. Ooh, that could be nice. But is this enough to let you stop? No. Well, okay. Maybe it fails the differentiable one, because I really want it to fail one, because then we just get to stop. But wait a minute, this isn't a polynomial whose derivative is a polynomial that I know whose derivative will always work. So what do you have to do to know if the derivative works? Find it. Well, don't you have to find it anyway if you have to keep going? Yeah. Alright, so it is what it is. You're going to be finding a lot of derivatives. So if you're going to take a derivative, P.S., look at number 2 and realize why he's going to be a really nice one in just about a second or two. If I'm going to take my f prime of x, to ask myself the question, I'm not sure yet, I haven't put a check mark because I don't know who the derivative is. You guys can be realizing why he's going to be nice. So bottom, the top, parentheses, some of you aren't putting them and they're messing you up. Minus top, the bottom, which is just 1. Okay. All over bottom squared. I really wish there was a nice little green pen trick. He has an x plus 2 and a 2 and an x minus 1, and he has an x and an x minus 2. None of them match. Well, if none of them match, you just have to simplify the old-fashioned way. The old-fashioned way, like foiling? Okay, my job is not teaching you derivatives today. So 2x squared minus x squared is x squared. And then we're going to have a negative 2 and a plus 4. That's a 2x plus 2x is going to be a 4x. And then I'm going to have a negative 4. When will that not exist? At negative 2, which is not on the interval. So does this technically work? Yeah. So what do you have to do? You have to do f prime of c. And set it equal to what? Oh, well, is it 0? What's the one thing I haven't checked yet? If that fails, can I stop? For Rolle's theorem, yes. For MVT, what would it tell me to do? Just keep going. You guys, why am I going to come over here and say f is continuous on? I know, you guys can start packing up. Although people got up early today. Why are they already here? Why am I going to put a no? This doesn't exist at 0. And what's true about 0?
It's his side.
Fifth side. Okay, fail. We're done. Done. So if it fails any conditions, you get to stop. And if it doesn't fail any conditions, you just keep going. Derivative equal to average. So, bye guys. Great job.